Okay, so today we're going to take care of lesson 5.5, solving systems problems. So up until this point, we recap so far the chapter and where we started. Our first lesson, 5.1, was just an introduction to the idea of what a system is. A system is a collection, a group of two or more equations, and we've been exclusively looking at just two equations, and that's what we'll continue to do, just two equations. And we've also been looking at exclusively linear functions, so a linear system. In our next lesson after this, we'll throw the parabolas back in. And we've also been developing all these little methods in order to sort of solve all these questions. So in lesson 1, we did solving by tables, and we saw how useless that was. We did solving by graphing. We saw the benefits of that. It's nice and visual, but maybe not exact. And then in lesson 5.2, we did our first of the 3 algebraic methods, which was comparison method. Then in lesson 5.3 we did substitution, and that was our second algebraic method. And then in our last lesson, 5.4, we did elimination. And I would think that most students, as you work through these systems problems, will probably choose to do elimination as sort of the #1 method to move forward with. But at this point, it'll be your decision on how you want to solve it. I'll solve it a particular way, and like I said, I'll probably use elimination in most cases. If you choose to solve it differently, that's fine. No problem, as long as you have the correct work and the correct answer by the end of it. So we've been exclusively looking at these shorter type questions, multiple choice level or short answer questions, where it's just kind of 1 or 2 steps, just solve the system, solve the system. We haven't put it into context. So now when we talk about actual problems here, we're putting this into context. So we're going to introduce the word problems and whatnot for today's lesson. We'll do a couple of examples. But all of these questions are going to be solved using the same procedure. So to solve a problem involving a system, again, we're looking at linear systems still, but we can easily take all of the methods, all of the tools, all of the procedures, and apply it to different types of systems moving forward. So we can still use the same process. But to solve a problem involving a system, here's what we'll do. It's pretty much 4 steps. The first step is we want to identify the variables. If you're wondering what do variables mean, in brackets I'll put x and y. So x and y are traditionally the 2 variables that we're using here, so we're going to identify them, which means describe what they actually represent. Then we're going to write the 2 rules. So which means write the two equations, find the system, the actual rules. Then we'll use any method to solve for x, or for the variables, I guess. I was going to write x and y, but really it's just any variables. Yes, it's true, we're going to be finding x and y. And then our last step is going to be to answer the question. Sorry, my pen's dying. See if I can switch pens here. Okay, now this might seem a little bizarre as to, if we're going to solve for the variables, how come we're going to answer the question? Because it could be that in some cases, when you solve for the variables, when you find the x and y, that's actually not the answer you're trying to find. The answer will be 1 step more. Okay, so we're going to do a couple of examples. We'll do 1 word problem, and then I'm going to modify that word problem and present it to you differently as a chart. And we'll do our second example after that. Okay, so let's do an example here. So we're going to solve a word problem here, so I'm just going to put that as the the description of what we're going to do, and then I'm going to write the question underneath. Alright, let's go ahead and do this. Derek buys 3 juice boxes and 2 muffins for $6. Kevin buys 2 juice boxes and 4 muffins for $8. How much does Jill spend on 5 juice boxes and 1 muffin? Just looking at my handwriting, I could definitely improve on that. Okay. So here's a word problem. And the first thing, so we've got our steps up here, the 4 steps. The first thing we're going to do is identify the variables, x and y. Basically, as you read through the question, we're looking for the 2 things that we don't know. Okay, so oftentimes the things will be tangible items. So you might look at this and say, okay, so the 2 things are Derek and Kevin. Those are 2 things. Sure, I guess if you want to call people things, but specifically, like if you're saying Derek is one of the variables, remember what a variable represents. A variable represents an unknown value. If you're going to say Derek is a variable, okay, then what do you not know about him? Now, sure, there's a lot of things we don't know about Derek. We don't know Derek's height, we don't know Derek's weight, we don't know a lot of things about Derek. But it's all irrelevant here. We don't need it to know anything about Derek because Derek is not a variable. Derek is not an unknown here. The unknown thing is something about the juice boxes and the muffins. So something about the juice boxes we don't know and something about the muffins we don't know. Now if you want to say, oh, we don't know how many juice boxes there are, well, that's not the case at all. We know how many juice boxes there are. We know in Derek's case, Derek has 3 juice boxes, so that's not an unknown. We know in Derek's case he has 2 muffins, that's not an unknown. We also know the total price that Derek pays. So the unknown here does represent something about the juice box and something about the muffin. And it's really the individual price of one juice box and the price of a muffin. So those are the things that we don't know. We don't know the price or the value or the cost of a juice box and the cost of a muffin. So those are 2 variables. How are we going to write that? We're going to define our variables as is. I tend to write it as sort of x and y with little colons beside it. You can write it in sentence form if you wanted to. So what don't we know? It's not good enough to just say that x is a juice box and y is a muffin. Because specifically we want to address what the unknown thing is. What about the juice box do we not know? Well, again, we don't know the weight, we don't know the size, but that's irrelevant here. Since we know that Derek is spending a total of $6, that means something about the juice box and something about the muffins would have to equate to $6. So it's the value, again, the price or the cost. So the cost of a juice box is unknown, and the cost of a muffin is unknown. Now, instead of cost, like I said, you could say price of, you can say, I guess you can get away with saying value of. You could even just put a $ juice box and $ muffin. That would be sort of the bare minimum. But if you just said juice box and muffin, without actually talking about specifically what is the unknown value of them, then yeah, you would definitely lose some marks there. So the cost of a juice box and cost of a muffin. Before I continue, I want to talk a little about my variables a little bit more. So when I say describe, or step 1, identify the variables, this is what step 1 is. Identify variables. That's what I've just done here in my solution, is identify the variables. How else could you have done this? Well, x and y are actually not showing you a dependency relationship. X is no longer an independent variable and y is not dependent, because the cost of a muffin doesn't depend on juice box. So there's no dependency relationship here, which means these are also interchangeable. So if you wanted to say x is the cost of a muffin and y is the cost of a juice box and flip-flop them, you're allowed to do that. You can do that. But it just means that as we continue through this question, everything that you'll get will be correct, it'll just be reversed, and that's fine. For me personally, How I identify them is the first thing I'll see, I'll identify it as my x, and the second thing that I read as identify as my y. So I just kind of keep it in order. Most students will also do that. Now, did we actually have to use x and y? No. I could have said, let j be the cost of a juice box and m be the cost of a muffin. I don't have to use x and y, but we are traditionally used to using x and y, so most students would do that. But again, if you want to call j the cost of a juice box and m the cost of a muffin, you're welcome to do that. Because the variables themselves doesn't make a difference what you say as long as you define it correctly. Okay, so those are the variables. The next thing we're going to do is step 2, up here where my finger's pointing at. It's write the 2 rules. Now, in easier questions like this, the rules are pretty much sort of the sentences that you read. We've got one sentence talking about Derek's total cost, and the second sentence talking about Kevin. Now, you might look at the third sentence and say, oh, we've got a third equation with Jill. No, that's what we're trying to find by the end of it. So this last statement, this last question, sorry, how much does Jill spend? That's actually going to be step number 4, is to answer the question. So if you focus on the first 2 sentences, we're going to get our 2 rules. The first sentence will give us our first rule. The second sentence will give us our second rule. Now, some of you can easily look at this and say, oh, yeah, I understand what I'm supposed to do. I'm just supposed to write the rule from this, and I can get that, no problem. For those of you that have a tougher time decoding it, what you can do is this. So we just define x as being the cost of a juice box. So everywhere you see juice box, you could just imagine scratching that off and putting an x right there. Everywhere you see a muffin, we just define y as being the cost of a muffin. So everywhere you see a muffin, you can scratch that off and put a y right there. Now when you see it, you can literally see it comes into place. 3 of the x's and 2 of the y's cost $6. That gives us an equation. So for Derek, 3 of the x's, and if I combine that with 2 of the y's, should add up to a total of $6. There's my first rule. Same thing for Kevin. I can come up with a second rule for Kevin. Again, if you really want to, you can imagine crossing out the juice boxes or taking out your eraser, erasing it, or even just taking out your whiteout and doing that. But this is essentially your x's right there, and these are essentially your y's right here. So I've got 2 of the x's and 4 of the y's should combine to give me $8. So 2 x's and 4 of the y's will give me $8. That's step 2, is to write the 2 rules. Now we have a system. But now once we have the system, this is what we spent the last week on, is developing all these strategies in order to solve it. And you can see it is set up really nicely to solve this by elimination. So step 3 is use any method to solve for the variables. That's what I'll do next. Is I'll solve using probably elimination here. Now most students, I said, will probably try to eliminate the x's, but you're welcome to do it any other way. But I'm going to eliminate the x's in order to continue, because most students, I think, would do that. Personally, I probably wouldn't. I'd probably actually eliminate the y's, because I just have to double the y's for the first one. But whatever. I'll follow along with how most students would do this. So I'm going to double the first rule to give me a 6x plus 4y equals 12. So I've doubled the first rule. I'm going to triple the second rule, which gives me a 6x plus 12y equals 24. So what have I done? I've doubled the first rule, and I've tripled the second rule. So by elimination, we can now subtract. My x's disappear. I get 4y minus 12y is negative 8y. I get 12 minus 24 is negative 12. Divide both sides by negative 8. I get y is equal to positive 1.5. Well, that should make sense, because what does y represent? The cost of a muffin. Does it make sense that a muffin could cost $1.50? Actually, yeah, it does. Those big Costco muffins, yeah, absolutely could cost $1.50. So there's my solution for the y. So what am I doing here in all of this? I solve using any method. Now, of course, I'm not done. I found the y value, but I haven't found the x value yet. So let's find the x value next. So I've got my y value. I'll replace it back into either one of my first rule or my second rule. It doesn't make a difference. I'll put it back in the first rule, I guess. So if I put it back into the first rule, my y value of 1.5, and go ahead and solve, I get 3x plus 2 times 1.5 is 3 equals 6. I'll subtract 3 on this side, so I got 3x is equal to 3. Divide both sides by 3, I get x equal to 1. Does that make sense? Could x equals 1? Could the cost of a juice box be $1? Yeah, absolutely, that makes sense. So I now have my solution. My cost of a juice box is right there, and my cost of a muffin is right there. That's step 3. Solve using any method. Step 4, I'm going to go back to the top here. Step 4 says answer the question. Okay, so let's go ahead and answer the question now. The question is actually asking us about Jill. Jill spends on 5 juice boxes and 1 muffin, so what will Jill's cost be? Well, no problem, we can do that. So for Jill, she's spending 5 of the X's. So for Jill, she's spending 5 of the X's, and each X is $1. And she's spending 1 muffin, and each muffin is $1.50. So 5 plus $1.50 would give you $6.50. This part right here is what we're trying to do, which is answer the question. So this is our first word problem, and you can see it is a long answer question because it requires multiple steps. You had the variable at the top up here. You have to write the 2 rules. You have to solve it, which is, again, that's the bulk of the work right here. That's the focus on what we've been doing the last week. And we tidy it all up and get an answer. That is supposed to be a very straightforward question. I would give my cultural students the exact same question. In fact, actually, I think I took this from their lesson. Okay, so what we'll do is we'll do a second question now, and it'll be the basic same idea, but I'm just going to package it differently. Because the big thing about these word problems are, yes, they can definitely become difficult, but once you get used to how all of them sort of present themselves, you get used to the idea of how to actually solve them all. Okay, so let's do a second question here. So this question will be solve the chart problem. I kind of break these down into 3 types of questions. Either word problems, which we just did, chart problems, and then picture or diagram problems, which we'll get into not today, but later on. Okay, so let's go ahead and write this down. A game involves picking colored marbles from a bag and scoring points as shown in the following chart. Okay, so I'm going to draw a little chart here. And in my chart, I'm going to have some titles here. So this is number of red marbles. This is number of green marbles. This is total points. And here I've got some people here. I've got Selma. I've got Oscar. And I've got Emmett. The question will be, actually I still need to fill in the chart, and I'll do that in just a second. How many points did Emmett get? So let me fill in the chart. I've got 3, 4, 90. 5, 3, and 95, 2, and 5. As always, you can hit pause if you'd like to get caught up. Okay, I'm going to go ahead and start this. So same type of question here, and if you're wondering how come I left that one blank, and yeah, that's what you're trying to find. So I guess that's the question mark if you want to put a question mark there. That's the unknown. Same type of question. In fact, you can even argue this is actually even easier to do because the presentation is actually even easier. Even though maybe not, it actually looks a lot more straightforward. Most of us will have a really straightforward time with chart questions. The first thing we want to do is identify the variables. I'll repeat, the variables are the unknown values. So my x and y are going to represent things that we don't know. So again, there are things that we don't know here. Sure, there are things about Selma we don't know. We don't know Selma's favorite ice cream flavor. We don't know whether or not Oscar has little brothers or sisters. We don't know Emmett's bank account number. But that's completely irrelevant here. What's relevant for this question has something to do with the marbles and points. So it's not the number of marbles, because we know how many marbles there are. That's not a hashtag, by the way. That's number of. So we know how many marbles that each person has. We know their total points. What we don't know is we don't know the number of points for each of the marbles. So my variables here, I'm going to write them right here, x and y. And again, I mentioned that you don't have to use x and y, but I will. I'll almost always exclusively use x and y because we're just used to seeing x's and y's. But you could have used R and G for red and green, I guess. So x represents something about the red marbles, and y represents something about the green marbles. X will have to represent the points, but it's not the points for all the marbles, plural. It's the points for one red marble. So number of points per red marble. Now there are different ways of saying that. Instead of saying number of points per red marble, you can say amount of points for one red marble. Instead of saying per, you could put a little slash there. But you have to be specific. We have to be talking about the number of points for a singular marble and not marbles. If it were marbles, this becomes really difficult. Yes, it's possible, but we don't want to do that. Y represents the number of points per green marble. Again, singular marble. So here are the variables. That's the identify the variable step, the first step. My second step is to write the system of equations. A chart is actually fairly nice. Remember I said that red and green, what you could do instead is you could imagine scratching this out or erasing this if you wanted to, and imagine that, okay, so effectively the x has something to do with the red marbles and the y has something to do with the green marbles. So you can see it really almost written as an equation. So for Selma, she's got 3 marbles and they're each worth x number of points. She's got 4 marbles, each worth y number of points to give you 90 points. So 3 of the x's plus 4 of the y's gives you 90. So Selma's rule would be 3x plus 4y equals 90. We can get a rule for Oscar as well. Oscar has 5 of the x's and 3 of the y's to give you 95. 5 of the x's and 3 of the y's gives you 95. We're trying to find Emmett. That means we can't really come up with a rule for Emmett because we don't know his total value. But we have enough here. These are our 2 rules, which means we can solve our system. And I'll go ahead and do that. I'll multiply the first rule by 5 and the next rule by 3 to give me a 15x plus 20y equals 450. Again, I'm doing this by elimination. And I've got 15x plus 9y equals 285. I'll subtract. The x's disappear. That's the whole point of elimination. The y's gives me an 11y. 450 minus the 285 gives me 165. Divide both sides by 11 and get y is equal to 15. Does that make sense? Doesn't hurt just to pause for a second and just ask yourself, does it make sense that y, the number of points per green marble, is 15 points per green marble? Yes, it does. What I mean by that is, let's say you got a negative value there. Clearly that doesn't make any sense. How are you going to get a negative value for a number of points? So it doesn't hurt just to stop for a second and think to yourself, does it make sense, these answers that I'm getting? Is it possible that I could have gotten a decimal? Yeah, it's possible. A little unlikely though, but it is possible. But crazy fractions? Yeah, probably not. Not in this case at least. So we have the y value. Let's put it back in and find the x value. I'll take my pick of which rule I want to use. I guess I'll just use the first one. So if I use the first one, I get 3x plus 4 times the y, which is 15, equals 90, which gives me 3x plus 60 is equal to 90. bring the 60 over to the other side. 3x is equal to 30, divided by 3, x is equal to 10. So now I have the points for one red marble is right there, and one green marble is right there. The question was asking me how many points did Emmett get. Let's go back to the beginning. Emmett had 2 red marbles and 5 green marbles. So let's finish this off and answer the question. So Emmett had 2 of the x's, which is 2 times 10, and 5 of the y's, which is 5 times 15. This gives me 20 plus 75, which gives me a total of 95 points. That's it. Homework tonight is worksheet 5. Tomorrow, by the way, we're going to be just doing word classes, and we're going to do definitely trickier questions. Both of these questions are cultural level questions, and we're going to step it up moving forward. How does it get more difficult? It's not here, it's not here, it's not here. It's going to come up with the rules. Is decoding the information to come up with the correct rules is the only way that this can get more difficult. Whether it's maybe more problematic in a word problem, maybe the chart's a little bit more confusing, although I'll be honest, the charts are typically the easiest. But it's normally the pictures of the diagrams that can be the most confusing ones of them all. So we'll continue that later on. Again, worksheet 5 is your homework tonight.